All right, let's start with some review. So I have x squared to the fourth power. So that means that I have x squared times x squared times x squared times x squared. And that leaves me with x to the eighth power when I add everything up. Again, the easiest way is to multiply those two together. All right, so x to the negative fifth times x to the third, and I'm squaring that. So my first step is going to be that I want to simplify what's inside parentheses. So if I had negative 5x's and then I have 3x's, that would mean that I'm left with negative 2x's. So I'd be left with x to the negative 2, and I'm squaring that. Now remember, I keep saying that the easiest way is to multiply these two together. So negative 2 times positive 2 is going to give us negative 4. So I'd be left with x to the negative fourth power. Again, remember that if I have a negative exponent, I can rewrite it as positive if I put it in the denominator. So I could either say x to the negative fourth, or I could say 1 over x to the fourth. And those two mean the exact same thing. All right, so for my next example, I have 5 to the negative third power times 2 to the fourth power. And I'm raising all that to the negative second power. Now the easiest way again is to multiply these exponents together. But I need to multiply both sets of these exponents together. So if I rewrite this, I could rewrite this as 5 to the negative third, and I'm raising that to the negative second, times 2 to the fourth, and I'm raising that to the negative second. Think about distributive property when you have to multiply everything inside the parentheses. All right, so then negative 3 times negative 2 is going to give us positive 6. So I would have 5 to the sixth power times, and 4 times negative 2 is going to give us negative 8. So 2 to the negative eighth power. All right, so I see that I have a negative exponent. So I could rewrite that 5 to the sixth power, and I'm going to rewrite this so it's in the denominator. So I'm going to put 1 over 2 to the eighth power. Now, we know that anything times 1 is going to give us itself. So if I do 5 to the sixth power times 1, I'm left with 5 to the sixth power. And then we're left with 2 to the eighth power in the denominator. And that's as simplified as you can make your answer. All right, for our next example, let's say that I have 3 to the sixth power over y to the negative 5, and I'm squaring that. So that would be 3 to the sixth power squared over y to the negative fifth power squared. So 3 to the sixth power squared is going to give me 3 to the 12th power over, and then negative 5 times 2 is going to give us negative 10. Now, remember, if I have a negative exponent, so let's just say I had x to the negative 3, I would rewrite that as 1 over x to the third power. Now, the same concept applies here, but the negative is in the denominator already. So if I move this up to the numerator, it now becomes positive. So that would be 3 to the 12th power times y to the 10th power. So think like if I'm flipping it from numerator to denominator, the sign is changing. All right, let's go over one more of those because I think that one's a little bit tricky. So let's say that I had 2 to the third power over 5 to the negative third power, and I'm raising all that to the fourth power. So I would rewrite that as 2 to the third, and I'm raising that 4 times over 5 to the negative 3, and I'm raising that 4 times. So 3 times 4 is going to give us 12. So we would have 2 to the 12th power. And negative 3 times 4 is also going to give us negative 12. So we'd have 5 to the negative 12th. Now, if I move this into the numerator, I'm switching the sign. So this would be 2 to the 12th power times 5 to the 12th power. And that would be my final answer.